Welcome everybody. My name is Michael Pollmeier, and in this talk we'll explore scalameta, or more specifically code generation in scalameta. I'll try and cover all experience levels, but there's going to be a few parts where things are probably more advanced, but I'll try and explain it with simple concepts, and please ask questions as we go. Can I get a quick show of hands? Who's been doing Scala for less than a year? All right, quite a few. Less than 2 years. Less than 3 years. Okay, so quite a mixed audience. That's good. Cool. Okay, a few words about myself. So I'm from Germany originally. I live in New Zealand, so excuse my accent. And I work for a company in Silicon Valley, of all places. I'm a member of the Apache Software Foundation, and I'm a Apache Tinkerpop committer. So Tinkerpop is basically the, you can see there's the JDBC of graph databases. And I'm the author and maintainer of Gremlin Scala, which is wrapping Tinkerpop basically and uses the power of Scala's type system to let you write safe traversals. I actually heard that a few people here at the conference are actually using it, and they weren't grumpy or angry at me or anything, so that's always a good sign. The company I work for is called Shift Left. We do static code analysis using graph databases. So we look for vulnerabilities, things like SQL injection and buffer overflows and stuff like that. All right, so the objective for today, or for this talk, is I'd like you to understand the basics of scalameta, so in particular the syntactic API and code generation, and the current project's status, so is it ready to use or what can I do with it. I would like to believe that it's already easier to use scalameta to write code generation than it is currently with the old style macros, and would like you to encourage to actually use it and use libraries that are based on scalameta. So before I show that slide, I was going to ask, who has ever written like an old style macro? Okay, and who's still maintaining that? And who's liking that? Okay, I was hoping all the hands would go down. Good. So that was my intro into scalameta. So I have in that library, Gremlin Scala, I have a macro that is serializing any case class into a vertex, so like a node in the graph. So that's a typical place for code generation. Lots of boilerplate, and it's quite easy to generate that. So, and that was written in an old style macro that someone else contributed actually, and the code was fine, but it was kind of, because the way it's all set up, it's kind of complex and quite hard to maintain. So I was quite pleased when I saw the efforts of scalameta. And actually, also macros now are going to be phased out. So currently they're still state of the art, but they're still sort of deprecated. And that's a good thing, I would argue. So they were quite hard to write and debug. There's quite a few rough edges, some edge cases that just wouldn't work, or you have to spend lots of time to make them work. And scalameta is here to replace it, and it already works with all Scala platforms basically. So 2.11, 2.12, Dotty, Scala.js, Scala native. And I just learned that if you write Scala on Android, because it's basically standard Scala, it also works like on Android. So that's pretty cool, writing macros for Android. If anyone thinks that's cool. Okay, some general terms. What is metaprogramming? So basically speaking, it's code that manipulates code. So you can do things like you can just verify the code. So that's not really changing it. That is just checking that it conforms to some standard. So for example, you have a database schema. You want to during a compilation you want to check that your code is compliant with that database schema, or it could be like some service endpoint or something, some HTTP endpoint. You can also change code, so you can inject things like performance metrics hooks. So for example, I don't know, you annotate some method, and every time the method is being called, you want to make sure that you count that somehow, or you want to see how long did that invocation take, something like that. You do that with annotations. Same goes for things like logging and so on. There's endless use cases. And you can generate some code, which is what we're going to focus on here. So you can, for example, so we're going to write a serialization macro that takes a generic class, some case class, and generates a to map. It could be a from map, so you can convert from a generic map into your case classes. Other things that we actually use is, for example, lots of shops these days are polyglots. So we, for example, have some Python code, some Go code, some Scala code, some Java code. And we have one domain model that we define in a JSON file. And you can then, based on that JSON file, you just parse it during compile time, and you generate your case classes for it during compile time. So that's something we actually do. Cool. So what is scalameta? Scalameta is a library that lets you do metaprogramming, right? So basically, the idea is you have a pipeline that you annotate some blocks of code, and they're being passed into the scalameta ADT, so the scalameta domain classes, if you want, and you can do whatever you want with that. So the way it works is at compile time, that's being executed with a compiler plugin. And what you get is some of these scalameta case classes. The domain model will see exactly what that means, and you need to return one of those as well. But in between, you can do whatever you want in normal Scala code, almost. And the way this is wired up is using macros. At least that's the way that I'm gonna show you. Cool. So one feature that scalameta has that is not the topic of this talk, but I just wanted to mention it, is you can basically parse code and do things like style checking on that. What you get, and this is quite a unique feature, and quite a new feature that you didn't get with the old style macros, is you get the complete AST, so the abstract syntax tree of the code. So you get all the white space, all the comments, all the Scala doc is a comment anyway. You get everything just as it is, as tokens and trees, which is really cool, and enables tools like Scala format, which allows you to use style and apply style information to your code automatically. And more recently, Scala fix, which I think is a really, really cool usage of this, which lets you basically write transformations for code so that you can automatically, for example, get rid of certain deprecation warnings. So if some changes have been, if some methods have been deprecated, and there's now a better way to do it, you can now, for some of them, apply them automatically. So Scala fix, for example, they wrote I think they wrote a script for scalameta. If you use like the last version of scalameta, to move over to the current version of scalameta. I mean, the changes aren't big, but you don't have to do anything yourself. You just apply that script. So I think that's pretty cool, especially going forward on our way to Dotty, being able to do that across like big source code, big code bases. That's pretty awesome. But a different sort of category in my head anyway for metaprogramming is code generation, and I think that's equally, if not more important, to me anyway. So one thing that I just talked about before, here's some code, is a generic serializer. So imagine you have some case class, customer with a name and a year of birth, and what you want is the implementation of that to map method. So you just have what we want to do is from the case class we want to generate the companion object or use it if it's already there, and generate this method to map, which takes an instance of the customer and returns you a map string any. That's what we try and do, and that's what we're going to do in the live coding session that's coming now. And exactly that use case was my initial my motivation to look at scalameta in the first place, because I had that exact use case. Like I said, there's countless others. Cool. So the wiring, I said, it's wired in with an annotation. So all we do is we add an add mappable, or whatever you want to call your annotation, in front of our case class in this instance, you can annotate anything you like, really. So you can annotate vals, vars, you can annotate objects, traits, what else is there? Types, you can annotate types, anything really. And then if you define your mappable annotation with this new construct, the inline meta construct, then that code gets run during compile time. So in that block, what you get is you have this one method apply, takes a definition and needs to return some definition. The type is any. There's some talk about that, but that's the way it is. So it's some definition, and you need to return some definition. So that definition is that is basically the scalameta domain model, right? So the instance of that class that you get is part of the scalameta domain model, which I'll introduce in the next slide. So inline meta basically become new keywords in the in Scala as we go forward. So that is the domain model. That is the ADT of Scala Meta. So Eugene and Stu just gave a talk, and they said, well, it's a very stupid model. It's a very dumb model because it's very simple. And it is very simple. So if you look at it, for example, the first one, that's something that you get into your inline meta block. So it could be an instance of defin.object, so the definition of an object, right? And that has things like modifiers. So modifier is something like case or final or private, something like that. So it's a sequence of these modifiers. It has a name, which is just the name of the thing, and then a template, which is things like it extends things or the body of the object. There's a class that has all these same things, and it has additional things like type parameters and a constructor. So that's all that's all that you get there, and that's basically all you need to do to analyze that class. That contains everything that how the class was defined. One important thing to notice is that there's different for names you see here in definite.object, the name is of type term name. Term is basically an expression, and in the class the name is of type type.name, because classes are types. So that's an important differentiation. But it's basically all it is. A name is just a string, right? It's just a stupid string, but it's just being wrapped in two different types, because it makes sense to differentiate these namespaces, to not mix them up, right? Accidentally. We see what that means later, but in practice. But basically, if you have a type name, that is, for example, if you use the class, if you want to refer to the class list, that is the type. If you want to refer to the companion object of the list, that's a term. So that's the expression. So that's the idea. And for the trees, so that trees, that's actually the source code of the trees. Here's the Scala doc for Scala Meta, and we can do, for example, if we search for the definition. So you can see here definition.class, for example. You can see all the things that I talked about. So name, for example, is of type type.name, and it has a template and constructor and all that. Right. So those are the case classes that you can use in Scala Meta, because in a way, Scala Meta is just a normal library, like any other Scala library. The other thing you can use are quasi codes, and they have been imported basically or re-implemented based on the quasi codes that we had in Scala Reflect. So in a way, taking over the good parts from the old world. There's a reference documentation that I'm not going to open right now, but I might go back to that later. And basically, what you can do with quasi codes, one thing is you can construct and deconstruct the scalameta ADT. So the class that the definite class, for example, that we had before, we can construct that using a quasi code. So a quasi code is basically just a string that contains Scala code. So you can write Scala code like that, just in a string, case/foo, and you prefix it with a Q interpolator, and what you get is an instance of definite class, which is the ADT that we had. So for construction, that is really, really cool. You can do the same thing the other way around. So you can deconstruct it. If you pattern match on it, you can pattern match on the quasi code, and extract while you're matching on it, you extract all these values from it. So in this one, you already extracted the modifiers, the type name, the type parameters. You extract everything from the class here. So if you need to get everything from the class anyway, that's a really good way to go about it. And these statements, I didn't make that up. I just got that from the documentation from the quasi code. So that's a nice list of contents where how you match on a class, for example, what you can extract from an object and stuff like that. But what I would argue, and I show that in the live coding part, is if you construct something, start with quasi codes, because it's just natural to a Scala developer. If you deconstruct, start with the ADT, because then you don't need to worry about, like, maybe you don't want to extract everything, or maybe you forgot something, or something like that. Cool. What you can do with quasi codes is you can nest them. So if you want to wrap that class that we just created, if you want to wrap that inside something else, so in this case an object, you just have another quasi code and you reference the class. It has a nice syntax for bringing in a list of things. So the second line here is other classes. That's a sequence of these classes, and it expands that into all these classes basically so it takes care of the sequence, flattens it basically. One thing worth noting is that there's like a few special quasi-code interpolators. So Q is like the default one that you go to an interpolator, but sometimes that's ambiguous. In this case, Q list, what you get is the term name. So that's the companion object, the name of the companion object of the list. If what you actually want is the type name, so the class list that you want to reference, one way to build that is to manually type, like manually instantiate type.name and then list. That's one way. Another way, which is equivalent, is just to write list in a string as well, but use the T interpolator. And there's other ones like param, and basically they're just there to disambiguate the quasi-codes. If they are ambiguous, this is how you can disambiguate them. We'll see some example of that as well. So now to the fun part, some live coding. What can go wrong? So the idea is I want you to understand kind of the pipeline of how it's being invoked. We'll try and do basically the same steps that a new user would make. So I try to kind of replicate what I did when I started playing with this. Maybe slightly faster than I did in the first instance, but I hope you follow along. And what we try and build is a generic serializer. So given any case class, the example we had, we'll implement that to map method basically. Cool. So we have an SPT project here. So basically, can you see that? Is the font size fine? In the back as well, all good? Cool, nodding. Alrighty. So 1 second. Cool. Okay, so macros need to be defined in a separate compilation unit. That is because the macros are being compiled into code that's then being invoked during compilation. So they have to be in a separate unit. So one way to do that is if you just have one project and you just want to use the macros inside your test code, that's fine. You can get away with just one project. Typically what you have is you have one project that contains some macros and some other project that is using them. So I just set that up in one build SPT here. So one macros. macros, and we'll see here we just have a dependency on scalameta, and forget the other one. That's like for some that's not actually important right now. And we have the compiler plugin for the Paradise, and then we have one project usage, which just depends on that. Two things to note here. One thing is we also have a transitive dependency on scalameta, but we can actually mark it as provided because we don't depend on that on runtime, because the code that's being generated is just at compile time. We also need the compiler plugin though, because otherwise it can't invoke the macro. All right. Cool. So let's have a look. Man, the font sizes are different. Okay, so this is our macro. So there's basically nothing in there. It's the inline meta block that I showed you, and we can I just added like a plain hello Scala Days, hello world thing just to see that it works. SPT, hello Scala Days. Okay, so we're running. So basically what I want to do is now I want to somehow invoke that thing, right? So what I can do here is I'm just going to annotate with the mappable annotation. I'm going to annotate trait A, for example, or let's annotate case class. Ooh. That's basically the one we're actually interested in. So we had a name, which is a string, and we had the year of birth, which is an integer. And then here, let's just see what we get. So we could just print the class of what we have here, because it's of type any, right? So what is it? We'll talk about IDEs a bit later, but I just want to show you the bare metal. So what we get is meta.definition, like we said before. So we got one definition of trait and one definition of class. Okay, awesome. That is good. So let's get rid of the trait because we don't actually care about that. And then let's see what we can do with the definition we have. So first of all, we can just pattern match on that. So we already know that it's a definition dot class. So I'll say case class definition dot class, just to see if that's actually the case. We just print line that, and we get the. Can you see that the sync to last line, the case class customer. So that's basically what we defined. Now that's interesting. So the next thing then is we wanna generate that to map method. So in the slide that I showed you, I just put that in the companion object of this class. So so far we just have a class, but we don't have a companion object. So let's just generate one. Okay. Let's be non-generic and let's just say customer. So this obviously only works for this specific case. And now what we want is we want to return the companion as well as the original class, which we didn't modify at all. Sorry? All right, sorry, thank you. Braces around what? No, I think that's. Yeah, no, that doesn't actually need. The braces. So just print that out before we return it, because we don't use it at the moment. so that's what we get now. That's the generated code. So we just create an empty companion object to that class. Way, awesome. But that only works for the case customer, so that's not so useful. So let us make that a bit more generic. So we just get the class name in here, right? Oh, there we go. So we have a different type here, but this is exactly what I talked about before. So we have two different universes of types in a way. In this case, we're well aware that it's a different universe. We just want to use that type, that name. So let's just wrap it in that. So we'll create a term name. So the compiler, it's compiler-driven development, right? So we have a type name and we require a term name. So let's just create it. So one way to do this term.name, and then we just get the class.name.value, which is the actual string, the underlying string, and then obviously here, term name. That should be good. So now it doesn't only work for customer, but also for customer too. Cool. Now say we wanna have a method in here that we wanna generate. So the toMap, which takes an instance of our customer. So we already have the so that's instance of type class.name, and it returns a map. So that's easy, right? Map.empty. String any. So that's what we're going to return. See if that works. Ah, sorry, typo. Cool. So now we can return an empty map. So now let's see if that actually works. So we can do print line of I'll say create a new customer. C and customer Michael. Ooh, can't even spell my name. All right, so we have a customer, and we say now we call the method that we just generated to map with that customer. Invoke that. So last line here, map. So we got an empty map. So that actually works. So compiled, we can call our method. Awesome. Now an empty map isn't always what we want. So to fill it, the first step that I always take when I do this generic programming is how would it look non-generic. So what I do is I just put in the code that I think the generic program should generate. So let's do that. So the map that I want should contain the members of my case class as entries, right? So one member is name, right? And the value should be that instance.name, so my customer.name. And the second member is a year of birth, and the value should be instance.year of birth. Right? And this is running it, and it actually prints out. This is actually using the values from my application, so that works fine for the non-generic case, right? So now we want to make it generic. One second. Okay. So to make that generic, we need to get the members of our class, right? Just checking the time here. Okay. Need to get the members of our class. So they are, as you can see in the in here. This is what I had opened before. So the Scala doc of the definition of class. Definition has a constructor, which is the primary constructor, and that constructor has parameters. So this is actually a list of parameters. Sorry, a list of parameters basically, because you can have multiple lists. We only care about one list, so we just care about all the elements in the all the members of the case class. So let's use that. So so we get class dot constructor. That's what we saw. Then I clicked on params. Oh, I showed you params. And that's a list of lists, so we want to flatten that into one list. Right? And we want to map over them. So for each param, we want to do something. Basically, what we want to generate is, scroll down a little bit. We want to generate exactly what we have here. So for each parameter, we want to generate the string of the name of the parameter, and then instance dot the name of the parameter. Right. So that's each for each parameter we want to do exactly that. So first we want to get the string of that. So param dot name the value. That's name is param dot name value. So that's actually just a string. And then the excuse the formatting and stuff. And then the code we want to generate is basically just something like this, right? So name and then instance dot something like that, right? So let's see what the compiler says. Almost, right? So the first part looks good. The second part, we actually need a term name, so we need to wrap it in a term again, just like we had before. So if we say term dot name, and then wrap that in. And there we go. So yeah, that's our generic implementation of ToMap. So that wasn't actually that hard. The code for that I'll give you a link after. That's all there. But I think compared to old Scala macros, I think this is actually pretty neat. And yeah, it's almost like a normal Scala library. It certainly feels like writing normal Scala code that you can now write to being executed as compile time, which I think is pretty awesome. Right. So that was that. So like I said, that was the actual start to my exploration of Scala Meta. What I did then is I sort of extracted out that serialization into a separate library that is open source, and there's the GitHub URL that you can use. It does exactly what I just showed you, plus a few more things. So all you need to do is you need to import the package, and then you can use it as down here. So you can call toMap and fromMap basically. So additional things that it does support is there's if you have an existing companion object, it keeps that, and any methods and any functions and whatever that are in your existing companion object or inside your class are being maintained. It supports type parameters on your case class, optional parameters, so get mapped to the wrapped value in the map. So if you have some 42, then it becomes 42. If you have none, then it becomes null in the map, in the resulting map. It supports default parameters. So here I is an optional int with the default value. So by default it's 42. You can change the wiring, so the name that the members are being mapped to in the map. You can change those. And if you don't want to work with options for some reason, you can also mark them as nullable, because by default it would say, hey, S is null. That's not a good idea. But if you actually need that, you can mark it as nullable. So yeah, so that's the kind of use case of that. Some advanced FAQ. For example, if you want to pass some value to the annotation. So in the example I gave before with code generation, we have a JSON file that defines our domain. So I want to pass the path to the file into my macro. How do I do that? Basically, sort of like you think, but not quite like you think. So you do define the parameter just like you would normally would on your macro. So it's a constructed parameter to your annotation. Sorry, I said macro. So foo becomes a constructor and a member of the annotation. But actually, inside the meta block, you can't actually access that. Instead, what you do, and this is part of the official FAQ as well, is you need to match on this in this instance, and that way you can extract it. So just a high-level one. If you actually want to do this, there's plenty of examples, and it's in the FAQ as well, just so you're aware. You saw that in the example for this serializer. You could I used other annotations inside the members of my case class. Those annotations, like add nullable, so to mark one member as nullable, those annotations cannot have inline meta blocks. I say this because, well, normally you don't actually need to. I don't think so there's some discussion on there. Is that even a use case? It probably isn't. But when I tried to do it, I intuitively just added my inline meta block, and I got some weird exception. So that's gonna get changed to some nicer error, because it actually doesn't make sense. You actually don't need it. But you can have as many as you like normal annotations, just normal static annotations. Inside that block, and you basically get them inside your macro. You get them as modifiers to those parameters. So you can see in your one macro, that's the add mappable. You do get the information that this member S is nullable, right? So you can work with that. Small print. REPL expansion for macros doesn't quite work yet. As in, if I go into my SPT project and I say inside the users project, I type SPT console. That doesn't work. So it's being worked on. It's gonna get fixed. But at the moment, the workaround is to have a third project. So you need a third compilation unit to actually make that work. Which, yeah, is a bit sad, but it's early days. So. IntelliJ and IDEs in general. So yesterday at Patrick's talk, I was surprised he used IntelliJ the whole way through. He did some live coding, and it all worked, and that was pretty awesome. When I tried for this talk, I actually had a few glitches, so I decided to not use it. If you do use it, you get some support from IntelliJ, and some of that is actually really cool. You can expand the whole macro and do all that. And also inside the macro, it gives the information from the quasi codes that you're matching. You also, I did also get some false negatives basically, so some red squigglies that were actually good. But I think they're on a really good way, and I talked to Michael, and they're actively working on it. If you do want to use it, you need to change to the nightly of the Scala plugin. And code completion works anyway, so that works really fine. So if I'm using my macro, I do get nice code completion for the to-map and so on. Enzyme and other IDEs that use the presentation compiler, so Scala ID should be the same. So the code completion works fine as well. So the to-map and from-map in this case, they're being completed fine. For some reason, I mean, I normally use enzyme, and writing the macro, I got some help as well, and that should just work. But for some reason, currently it doesn't. Not sure. Yeah. So the state of IDE support is kind of, it's looking good. We're moving in the right direction, but it's not quite, hasn't arrived in the stable releases yet. Yeah, and just to wrap up, I think scalameta is a really awesome metaprogramming library and has a really cool DSL to do that. And it's a dumb DSL, which is really cool. And because you don't need to understand all the compiler internals, and it's quite fairly simple on the surface. You do get support for all the Scala platforms, like I said before. There's still some rough edges. We talked a bit about that. IDE support. There is a really active and responsive community, so that's really cool. It's a small community, but people are very responsive and happy to help out. The Scala doc that I showed you, that should be hosted online, really. I serve that locally. And most importantly, it needs a logo. So if we have designers here, I think there's some work to be done. Cool. Some references. So that's my blog, and you'll also find that presentation on there. My GitHub, which contains well, Grammar and Scala, obviously, but also the repo that where I did like all the steps in this talk, and also a few further steps. So the from map is in there as well, and like a generic case class generator based on a JSON file that's in there as well. And my Twitter, if you'd like to follow me. Yeah, thank you.
So you mentioned code generation as being one of the use cases for this, but would that be called macro expansion into like generating the to map and from map? And if so, then is there a way to use like inline to actually generate code files, like serialized out external from?
You can do that if you like in your, so what you can do is you can just use this mechanism to invoke the macro, to invoke that inline meta block, and then in that block you just don't do anything, but you write to some files, right? You can do that as well if you like. It's just Scala code. You can. It's just at a different level basically. So if that's what you want, yeah. I mean the benefit is obviously that you then actually see what you get. The thing is, and often people need that. So for example, for the scalameta serializer, what I did is I added like a configuration flag that you just in the macro. If you define the macro on a class and you basically say debug equals true, then what it does is on the console it actually prints out the code that is generated for you, because then it's a bit easier to understand because you might not have the IDE support yet, or something might be missing because that's not stable enough. So some print line debugging is actually quite helpful there. So.
Yeah. If there are multiple annotations, meta annotations applied, in which order do they get invoked, and what code do they see each?
I don't know, Eugene. If there's multiple meta annotations applied, does that even work? Oh, it does. It should work, he says.
So macro annotations, they expand outside in, which means the outermost annotation will expand first, and then the innermost annotation will expand next, if it hasn't been removed by the previous macro expansion.
So in the use case you were showing, how hard is it from your case class with the annotation to find the companion object to see if it already exists?
That's very easy. That's very easy. So I showed you on the when I match on the definition. The only match I had was case.class, definition.class. If you this is in the FAQ as well, in the official one. If you instead match on a class and basically a definition of class and a definition of object, then it finds that it matches every time the companion object is already there. So you can see the code in the Scala meta serializer as well. It's two very simple matches. What you can do as well is you can match using quasi quotes. So you can say quasi quote and then definition.class, definition.object basically, and then you get the existing ones, and you can just add your code into the object. And it's really straightforward. Yeah.
Just wondering, I think one of the things you might have mentioned early on was that the old style was hard to test, and I'm just wondering, is the new style here, is it easy to write unit tests or things like that? Is that even possible?
So what you typically do, and what I'm doing in the serializer is you test the results of it, right? So you, I mean, that's always what to do if you write some unit tests, right? You test the code that you use the code and you test the results. So if you look at the unit test for the serializer, I just create these case classes with different things and use different annotations inside the members, and I make sure that when I run it and I generate the two map, that I get the expected results. So in a way, that's just testing like any other Scala code. But that also goes for the old style macros, right? So if you, when I said the old style macros are not so good for certain things, I didn't technically imply testing because for that it's basically the same. It's more trying to debug if something doesn't work, or well, write them in the first place or maintain them. That's just, it feels much simpler with scalameta. So for anything new, so I would definitely go for scalameta first.
So I'm trying to wrap my head around the model here, and I noticed there were two keywords, inline and meta.
Yeah.
Can they be used independently? Can you clarify why we need two keywords?
I didn't come up with that, but so technically inline is a new keyword. Meta is actually something that Eugene has just made up in a set. So basically, in my head, that's just the boilerplate to invoke that. This is where you define your macro. Do you have something to add to that? Yeah.
Yeah, so inline is a new keyword. It can be used independently from meta, just to do regular inlining. Previously, you had to say at inline. No, just there's a keyword for that. And meta can also be used outside of inline methods. For instance, yeah, I don't know, you can just write a meta block somewhere in your code and then have the contents of that block be evaluated and then inlined at the call side. It's like anonymous macro expansion, you would say. So these two concepts, they roughly comprise an analog of what we have with Scala Reflect macros. And there's a Scala improvement proposal just for that, which is inline/meta. You can look it up on the internet.
All right. Last question. I think we're running out of time.
Okay. Well, in this case, you had a case class with primitives. What if I have a case class with other classes and it just goes nested? Would it work? And if so, how many levels deep can you actually go recursively in your Quasi code's code?
In the Quasi, well, there's two things, right? So if you already have well, what you can do is you can see if something has a certain method inside, right? So if your case class, if you want to serialize, contains another member that also has the two map, or also has a companion object that contains the two maps, and the serializer I'm actually generating type classes for that. So you could check that and invoke them. So I haven't actually tried that, but I don't see a reason why you couldn't do that. In the same way you can, I mean, the last question was on quasi codes. How far can you nest them? You can nest them indefinitely. So if you just you create one quasi code that references another thing that was a quasi code, just like normal Scala. There's no difference basically. Right. Yeah, that's actually really cool. So I repeat that because you didn't have the mic. So you can basically, while if you find another case class in there that doesn't have the two map, you just while you're parsing the outer map, the outer case class, you just add the annotation. You just add the mappable, and then in the next step, it will get invoked again. So that's actually pretty awesome. I haven't actually tried that, but it sounds pretty cool. Yeah. Okay. Thank you.